Abanye benu bayokhala kwasho lugeze ehlekile. Okay guys, let's continue. Now we did the first part in the part 3 video. I don't know, we were asked to find the deflection at the free end. Now we have to find the deflection at C. So I already prepared a sketch here. So now they ask us to find the deflection at C. Similar with the slope, they can ask you to find the deflection at C or any point that matters, right? So remember what is really important. Remember the formula. This one, YA minus YB is equal to X bar over EI integration from A up until B M dx. Remember this formula. Right, we need to know one thing, right? And then this is where they ask you. So what they asked, the deflection at whatever point, you see. And then the area is from that point up until whatever you know, B in this case. So this is a conventional for what do you call this? The error method formula. So what do you do? Let's start here. The wall is your friend, remember. So we have a wall. So automatically we know that YD is 0. Also theta D is 0. We know that. So we're gonna use the wall as our friend. And then we ask for a deflection here at C. We are no longer going to A, but now to C, right? But first thing first, we're still gonna use the superposition principle. So our step 1 is to use the simple principal position theorem. So again, always start with point forces to make your life easy. So now we're gonna start. Let's start with the 6 again. So we have a 6 here, and then the distance, we have A again. So distance from A is what? It's 4, and then from here to here is 2, right? And then we have a wall. Then again we draw a bending moment diagram. So we have something like this. You draw, so 0 0 0 0 0. So this is your A, 0 0 0, and up until D, C. Then you draw. So yeah, moment at C is 0. Moment somewhere here, it's somewhere here, and then moment at D, it's what? 6 times 2. So it's gonna be minus 12. Remember, 6 is going down. So this is minus 12. This distance here is 2, and this is 4, right? So let's continue. Before we continue, let's just name this is 1, and then just do it. So this case, let me just zoom it so that you can see. So we have something like this. I want you to zoom at C. So you have something like this, minus 12. I'm zooming it. So we have something like this, right? So they ask us to find the deflection at C. So now our X bar is gonna start here at C. It's no longer starting at A because they ask us the deflection at C, right? So again, you can call it area 1, right? And then the area that we are looking for now is between C and D, right? So in this case, 6 is not cut, it's not anything, it's still 6 because it's still 2 meters. So area 1 again is equal to 1 over 2 times 2 times minus 12, right? Then now from here to here, this is your x1, x bar 1. So what is my x bar 1? Now we're starting from here, not from A, because they asked the deflection at C, not from A now. We're starting from C now. So from here to here, what is it? So still the full rectangle is still here, the full triangle is still here. So it's gonna be 2 over 3 times 2. That is my x bar. Done. Then let's continue again for 9,7. So we have something like this, 9,7. And then the distance from here to the wall is what? It's 4. It's 2. Take note, they asked me the deflection at C, but I'm gonna include everything. You draw everything as if they ask you from B. Then let's draw now. So I have something like this. I'm gonna draw big so that you can see. So we have a D, and then from moment at A, it's 0. Moment at B, this is B now. Moment at B is what? Moment at B, it's 0. And then from here, we have a point okay, let me wrap this one. Let me just draw it here because it's going up. So we have A, and then point B. And then from point B, we have something like this. So moment at here, it's 9.2 times at B is 0, then 9.7 times 4, still 38. 38,8. Always do this. That is the first thing. Then this is point D, right? And then again, they ask the deflection at what? Point C. So we draw a dotted line here, right? So now we're going to focus only on this area. This area is not included, only this area, because we are dealing with CT. Remember, if you are integrating, we're going to be saying C up until D. You see? So it's the same thing here. C to D. No, you don't include this one because they say deflection at C. We know D, we don't know C, right? So now look, obvious this is no longer a right angle triangle. So we have two things. We have 1. So obviously if this was 1, this is 2, and this is 3. Now we have to find what is this point. How do you find it? Just go back here. So what is this distance to C? It's 2. So it's gonna say 9,7 times this distance. So 9,7, take the moment, 9,7 times 2 is 19. So this is 19,4 because we say 9,7 times 2, or you can even use slope hook, but just always go back to the bending moment. You ask whatever point. So if they ask you at maybe at this point, let's say this distance is 3, you're gonna say 9,7 times 3, which is what's gonna be somewhere here, right? Remember, this line is joining all the UDL after the bending moment after. So we have something like this, right? Then we have this area and this area. We only include this shape. Let me just highlight it because they ask us the deflection at C, and we take a wall as our reference, so they only ask us here. We don't care about this, right? Similar with, okay, English is not my friend. Similar with X bar. Remember, for this one, the triangle was still here. Now we have new X bar. So we have new X bar. You can call it, this is X bar 3. From here to here. Remember, from C, they ask us the deflection at C, not at any point. From here to here, we have another x2, right? Now let's find it. So area 2 is equal to what? What is my base? Here is 2. So it's going to be 1 over 2 times, what is my height? So from here to here is 19,4, so the difference is still 19,4. So it's gonna be 19,4 times the base times 2. Remember, this one is positive, so yeah, this one is negative. Then x bar 2, what is my x bar 2? From here to here, right? From here to here. So we have a full triangle here, so it's gonna be 2 over 3 times 2, because the from here to here is 2. Done. Then again, area 3 is equal to what? This is a square or rectangle times 19,4. You have your answer. And then x3 is what? From here to here, it's just 1. 2 divided by 2 is 1. From here to here, it's 1. You see? Then let's continue. We have now a UDL. So UTL, then we have 1 meters here, have A, and then we have not C, C is somewhere here. Let's call this point E. Then we have this UTL of 2,2 kilonewtons, right? And then the distance here is what? 5. Yeah, it's 5. Then let's zoom it also, make it big. So again, moment at here is 0. And then we curve up until E. So E is somewhere, let's say it's somewhere here. So let's curve. We curve up until here. We curve up until E. So this is our point E. And this is our, let's say this is our point C. Even though it's not aligned, it does not matter. So this is our point C. Right? And then from here, it curves up until here. Remember, the UDL ends at, it starts at A and then it's curved up until E, right? And then from here, it's what? So what? How many shapes do we have? So if this is our C, so from here, we're gonna deal with, again, we are dealing with this area, a curve here, this area. Why? Because the integral says from A up until B, so in this case it's from C to D, because they ask us the deflection at C, right? The deflection at C. So we are focusing on here, only here. So how many things we have? We have a curve here, right? And then we have this, we have a, and then also we have something like this. Right? So if this was 3, we can call it 4, we can call it 5, we could call it 6, we could call it 7. Remember, this one is curved, this one is just a straight line. This one is 1 meter, and this height from here to here at C, so it's gonna be what? The distance from here to here at C is what? 4. So it's gonna be 2 times 4 times 2. Half of 4 is 16. So from here to here it's what? 16 minus 16, because UTL is going down. Then from here to here, remember the UTL is not finished, so it's gonna be 2 times 5 times 2,5. So this here is what? Minus 25, right? And then from here to here it's gonna be 2,5 times bracket 2,5 plus this distance 1. So here it's got minus 35, right? So we have this length, so it's minus 25 here, it's minus 35 here, right? Already we have numbered. So again, let's do it. So we have 4, 5, 6, and then we have 7. We have many things, so we must be careful. So again, even my x starts at what? At C. So we have x4 here, we have x5 here, we have x6 here. Yeah, this is 5. Remember, the 5 is this whole thing. Remember, the 5 is this. We have 6 here, x6. So we have something like this. Now let's calculate. So we have area, the distance from here to here, it's what? From C to E, or it's 1, because from here the whole distance is 1, so it's 1 here. We don't care about this one now. Yeah, we don't care about this one, but yeah, this is my A, but we don't care about, because they ask us the deflection here. So we have what? A4 is equal to what? So A4 is this. Let me make it clear. So A4 is this. There's my A4 is this square or rectangle, so it's gonna be 1 times minus 16. That's it, right? And then my x4 is from here to here is just 1 over 2. 1 divided by 2, which is 0.5. Then again, a5, so we are talking about this. So it's going to be 1 times, what is the height here? Minus 25 times minus 25. Right? Not 16. Don't divide it further because you can see simple shape. Then x5 from here up until here. It's what? It's gonna add 1. First there's a 1 plus 1 over 2, which is what? 1,5. Right? Then we have 6. A6 is what? This right angle triangle, right? So it's gonna be 1 over 2 times 1, the base, and then times from here to here it's what? Minus 35 plus 25 is 10. So it's minus 10. Right? And then x6 is equal to what? From here to here it's what? 1 plus a 2 over 3 times 1. Because this is a right angle triangle. Right? Then you have your equal, and so on. Then lastly, we have this small. So we have something like this, a small one now. You have a curve. So this one is similar to, you have a curve, remember? So this curve is consistent. So you can assume the distance from here to here is 1 over 4 of this base. So from here to here is your x6, x7 I mean. So area, let's assume area 7 is equal to 1 over 3 times, what is my base? 1. What is my height? It's minus, so my height is what? Minus 25 plus 16, it's 9, minus 9. Then the x7 is what? We assume, we say 1 minus 1 over 4 times 1. Remember, this is a parabola, right? Which is equal to, yeah, guys. So then afterwards, you say your YC in this case, deflection at C is equal to, remember the wall is D, 0. So we have, in full we have something that YD is equal to, YD is 0. And then a modified version of this equation, so it's gonna be sum of A1 XI over EI. That's it. And then we do the same thing again, say x1 times a1 plus x2 times a2, and so on, guys, and up until x7, and then we divide it by EI. Again, the EI here is what's given here. And then the final answer is what? You need something close to 7.5 millimeters. Remember to convert. Remember, these are kilonewtons. This is a SI unit. Convert times 1000. Right? Tell me the answer in what you find here. Right? Same thing if they asked for the slope. You are gonna go slope at C is just equal to what? AE over X. Not X over EI, right? Just the sum of area. So never just sum areas and then multiply each, and then times 1000 divided by E. Done, guys. Right? Now you're gonna go and study for yourself how to do it for the built-in. I'm not gonna show you. Also, if there's missing, like for example, you can On Drotsky you can try 14.7. Right, you can try 14.5 whereby there's a missing. 14.5 whereby, let me just draw it for 14.5 for you. 14.5 look like this. I don't want to draw it, so go buy a book and then 14.5. You're gonna do it, try it, and then on built-in beams or whatever, you're gonna research it, but this is the best explanation. So whatever question you have, whatever problem you have, do comment on it, give a link, Google Drive for that problem if you have a problem, and then we try to figure it out. Not something complicated, just something basic. I don't really have time. Just anything.